In this video, we will talk about how to leak Libc base address by using heap-related vulnerabilities. In our previous video, when we talked about use after free vulnerabilities for fastbin, we mentioned that we may want to use malloc symbol and we might want to overwrite the value inside malloc. In order to access malloc, we need the base address of Libc. Because if the library of Libc is dynamically linked, we will only be able to get the malloc, which is the offset of the start of the Libc. So we still need to know where Libc library is dynamically loaded to a program when it is executed. And this comes to the question that how to leak base address from a use after free vulnerability. Actually, you can also use other vulnerabilities, but for now in this video, I'm going to just talk about this by using a use after free. And specifically, I will talk about two approaches. The first approach is to find a fake chunk that contains Libc info and also satisfies the necessary condition for fake chunk. In this way, we can link the fake chunk to an existing fastbin chain and then reuse the use after free vulnerability to get the specific chunk and read the information over there. For example, in this case, I just searched the memory and then I found that memory 602248 contains the information of a heap-related memory. And also, it has those 0 zeros, which is necessary for fake chunk for use after free vulnerability. Therefore, I'm going to use this address as the start of the fake chunk, and then I can take advantage of a use after free vulnerability to link the chunk with a known existing chunk in the fastbin. After that, I can just follow those essential steps of attacking a use after free in fastbin. For example, I can just do malloc to empty tcachebin's chunks. And then I'm going to do another malloc again so that after those moving, the victim chunk will be in the head of tcachebin. And then I can do another malloc to get the victim chunk and read the information over there. The disadvantage of such approach is that usually finding a fake chunk is not that easy. And sometimes it really depends on the luck, because you have to find a specific memory that satisfies all the conditions to be a fake chunk, as well as contains the information regarding the Libc's memory. Also, such approach will not be able to work if the address of the fake chunk also changes when the program is executed. For example, in our case, the address that I find is related to the execution of the program. This is inside the data segment of the executing program. So if the program is without PIE, without pi, then I can use this address because this address will be permanent. However, if the program is pi enabled, then every time when the data segment of the program is loaded, this address is going to change. So I cannot use this as a fake chunk because I don't even know where the fake chunk is. Therefore, there is another approach that we can use, which is to take advantage of assorted bins. If you still remember this layout of assorted bins from last week's video, you know that for inserted bins, it has both forward and backward links. And the start of assorted bins is in arena, and from arena, which comes from the data segment of Libc, it will link to the rest of the chunks. Therefore, we can take advantage of the structure of a sorted bin and try to free a chunk into a sorted bin. For example, here, I am showing the case that there is one free chunk in a sorted bin. The left chunk is in main arena, which is also in the data segment of glibc. And starting from this initial chunk, it will use the forward pointer to point to the freight chunk. And actually, it will also use the backward pointer to point the same chunk. But for ease of presentation, I'm not going to show the backward pointer. I only show the forward pointer in this case. And then looking at the right-hand side chunk, which is the freight chunk that is saved in a sorted bin, forward pointer will point to the main arena. So if we have the assorted bin and if we can read information regarding the assorted bin, then we'll be able to get the address of the main arena. Starting from there, we can then locate the base address of glibc since the offset of the chunk will not be changed. And in fact, if you're using PonderBack, you can get such information by looking at the sorted bin layout as well as the arena layout. So here, for a sorted bin, we notice that this is the start of the sorted bin. So this is the first chunk, and then the first chunk would point to the main arena's related offset. And similarly, if you look at main arena, you will notice that the first element of the bins, which is related to a certain bin, will point to the start of the assorted bin, which is the first chunk that is stored in a assorted bin. Using such information, we will be able to locate where this main arena with a specific offset. And from there, we will be able to locate the base address of Libc. And working on how to leak the Libc using assorted bins. Of the service so that right now, if we're interacting with it, you will be able to read the content according to the index. In this way, we will be able to read the content from the chunk, and from there, we'll be able to get a leaked Libc address. And now let's open the demo. And I already implemented the read specific instruction, the utility function that we can use. And now let's work on the part of Libc leakage. So we're going to follow the approach that we have talked about in our slides. Recall that the first thing for us is to write the layout. So we need to set up the layout of a sorted bin. After that, we need to read the content of the sorted chunk. And then, given this value, which stores over here in the forward pointer, we will then use this value to compute the base address. And then followed by this second step, we should be able to get the base address of Libc. Now let's fill in those steps. So the first one is to set up the layout of a sorted bin. In our case, we are hoping to have one chunk in a sorted bin. Note that you don't have to have only one chunk. You can have more chunks. It just, in our case, in the demo, I'm going to have one chunk since one chunk is sufficient. To have such layout, we want to make sure that the chunk is large enough so that once the chunk is freed, it will not go to fast bin. So that now I am going to malloc. We have to malloc more than 7. So right now I'm just like malloc probably about 10 chunks. And that should be enough for us to put some chunks into a sorted bin. And I'm going to just use an arbitrary size. As long as it's larger than hex 80, we're good. And then after that, let me just fill the T cache first. And then I'm gonna put one chunk to unsorted bin by free. Suppose that we just put the chunk number 7 to unsorted bin. All right, so let's validate if this attacking code is same as what we expected. So we could set a breakpoint over here. And run it with GDB enabled. Cool. So after that, right now, because of the breakpoint, so if we do continue, we notice that the attacking script stops at the breakpoint. And then now let's go back to the GDB. We set a interruption over there. And then right now, let's take a look at our bins. Good. It is as expected. So the next we need to do is to read the content from over there and then subtract that with the offset. Then how to get the offset? Now we know that in the current process, here is the pointer that is recorded in a sorted bin. And this pointer is in main arena, which is in the data segment of glibc. So then let's take a note to remember that this is the address that we can get from a chunk in a sorted bin. And then if we use vmmap, we will be able to get the current base address, which is here. Cool. So now in this case, we'll be able to get the offset between the address that we can get and the actual base address of Libc. Now let's exit it. And then let's just remember this two value. I'm gonna write this in notes. And then go back to our attacking script. We're gonna put this to address somewhere. We know that we will need it in the end. So let me just put it here. Current pointer, which is equal to this one. And then current base is equal to the next one. So that we can get the offset, which is equal to the current pointer minus current base. And then let's remove this so that we can continue to program and later on have the program to execute. The next part is to read the content of the chunk in sorted bin. Keep in mind that the bin that we freed and also the chunk that goes to a sorted bin is with the index of 7. So we can use read 7 and that will give us the address, but it's in bytes. And then next we need to convert the address from bytes to the actual integer. And the way that I'm going to do is to use the U64 function coming from Pwn Tools. And then I'm going to manually add a padding for the byte because the output that we get from the service may be cut off due to the fact of the integer. So here what I'm doing is that I'm going to check the length of the bytes that we receive from the service. And if that is smaller than 8, then we can, calculate the number of bytes that's needed to be padding. And then I'm going to put this padding in the end of the bytes of the address because the entire address is in little endianness. And then I'm going to convert that to an integer using U64. All right. And after that, we can then just use this address minus the offset that we just calculated, and that should be equal to the current, the actual base. And then now let's just return this. And meanwhile, let's print this. And I'm going to print this in hex because usually when we represent an address, we're going to use the hex base. All right. To validate if our calculation is correct, we can still use GDB. And you can set a breakpoint before you return. You can actually set up this breakpoint somewhere else, but here I'm going to set this right after the print because I want to make sure that I can find this printing message very easily. All right, and now let's do GDB again. And also, I want to make sure that when I use GDB, my ASLR is enabled for sure. So in this case, yes. And if you don't specify ASLR, you're also good to go because ASLR, the specific argument, is set to be true by default. Now let's use GDB. And then the program stops. Let's have it continue. And then go back to our attacking script. We find that this is the address that our attacking script outputs, which is the base. Okay, and now let's go back to the GDB. Let's interrupt using Control-C and then do VM map. We can get the current start of Libc. And then if we check this to value, you find that they're the same. Great. Now we manage to leak the base address of Libc using a sorted bin. And once you have the base address of Libc, you can then use this address as the information that is fed to the attack of the fast bin used after free vulnerability.